Well, I'm still kind of in a state of flux as far as deciding which direction I'm going to go with this thing. But I decided that even if I'm going to seek out another lower unit, I still want to get this one apart. Because if I end up getting another lower unit and I end up having no problem fixing that unit up and using it, I'm going to want to disassemble this unit to at the very least get the gears out of it. The forward and reverse gear and pinion gear look like they're actually okay, as does the dog, the shifting dog. So if I can get all those parts out, maybe I could sell those on eBay or somewhere and recoup a little bit maybe of what it would cost me for the used lower unit. So in an attempt to get this apart, what I've now done is I mounted my vise. The reason why I'm over here on this back corner is because my workbench actually has holes already drilled in it for mounting a vise over here. Not where I normally work, but so who cares about that? Main thing is now I've got the vise mounted to the bench. I've got the pipe jaws of the vise actually clamped firmly on this shaft. Last night I was trying to get this off with the box end wrench, but the box end wrench kept popping off, kept having the same problem I was having as over there. So I decided to go back to a socket, and this is a method that was recommended to me by one of the contributors on the Scream and Fly website. He had said that basically put the wrench in there, allow the housing to push on the wrench, and have the thing firmly clamped in the vise, and then just twist the whole lower unit, and that should turn the nut. There it is. So, hey everybody. So last night I was down here and I worked on getting the nut loose that holds the pinion gear on the end of this drive shaft. And I was in the middle of doing that and the camera shut off and the batteries had died and I didn't realize that I forgot to charge them. So anyways, I actually stopped because I wanted to make sure that I showed how I was able to do this, because it ended up being James again came through to the rescue there. He's a contributor on the Scream and Fly website, and he gave me a tip. This is the procedure he's used. So I bolted the vise down securely, and I've got the shaft clamped in the vise there. And then he uses a box end wrench, and I was having trouble with the box end wrench slipping off. And I think if I had a box end wrench that was straight orientation here instead of this curve, it would be okay. Because what happens is you put the wrench on, and then you bring the body of the thing down to push on the wrench, and then twist the whole thing, because you get a lot of leverage here twisting this. And it kept popping off. And I think it's because it's not really lining up with the top here. It kind of wants to push it off. So what I found was that if I take the breaker bar and socket, I was able to get this to line up much more on the top of the arc, which seemed to solve that problem of it popping off. So I did break it free last night. So now I'm going to just use a ratchet to take it off a little further. And then the next tip would be to actually not completely immediately remove the nut all the way. The idea being that if you loosen the nut, without taking it all the way off, I don't want to go too far. Okay. What I should be able to do now is actually give this a whack with a dead blow mallet, and that should cause this to move this way far enough to pop that pinion gear loose from the shaft. But the reason why I don't take the nut all the way off is so that the whole thing doesn't come flying off on me and hit the floor. Can't quite tell if it's worked or not. The other thing I wanted to mention was I wanted to, no, that hasn't moved. I wanted to bring up the fact that today is, today's date is September. Usually I mention, or I try to sometimes mention the date in these videos so people can get an idea of how, because by the time I get these videos all put together, edited, and uploaded to YouTube, oftentimes quite a bit of time may pass. So, for instance, right now, today is, I believe, September 9th, 2016. So, I'm going to give you an idea, because sometimes people will make a comment. Oftentimes they'll give advice or something like that, and the irony is that oftentimes I've already figured out something. But by no means would I want you to stop giving advice, because you also may say something that I didn't figure out. But so where we stand on this, basically I'm still kind of in a holding pattern here. The other thing is that this, what looks like a sleeve down here, it appears that this sleeve that I was talking about down in here might not be a sleeve at all, and it might just be that the way this is made, that they machine it out this way. The reason why I'm bringing that up is because I can now see clearly that the crack in my casing goes right through the area where that thing that I thought was a sleeve actually is. It's almost like a transition point. I think what I'm going to do is I'm going to get a photo of that, and then I'll splice that into the video so you guys can see what I'm talking about. Alright, so I'm not on the tripod. I'll try and hold this as steady as possible, but you can actually just see the crack right here. That line right there is the crack. And if you'll notice, it actually travels right down to here and matches up with this line that's just visible right here underneath my pointer on what I thought was a sleeve, this area here. So that crack continues on down past this point. It crosses this transition point right here. More specifically, right in this area right here, it's cracked. The reason why that's a big deal is because this is the area where that O-ring has to expand and push up against. Okay, so my problem is that even if I weld on the outside of this casing, there's the possibility, the very real possibility that oil might try and migrate along this crack on the inside and get into the water side, or vice versa. Water might migrate along this crack on the inside and get into the case. So welding this up and making it so that this is a positive seal is a completely, that's a whole nother kettle of fish. In fact, you could make the argument that from this O-ring point right here, bearing surface right here, from this point forward, or I should say aft, towards the back of the case here, all of that crack area right there really is structural, and you know, you obviously you'd want to weld it for structural purposes, but it's not going to really have anything to do with sealing. If water leaks from the outside of the casing through to this inside, this area is exposed to the water all the time anyways. It's the area from this point here back that way that's going to be the area that normally should be filled with oil. Okay, so I could see that space between where the nut is unscrewed and the face of the pinion gear in there. So that tells me that that pinion gear has not yet popped free. Ah, that's tight. What if I could put a screw jack down inside there and push that out? Hey everybody, it's September 11th, 2016, And today I decided that I wanted to run this motor again in collaboration with some people on the Scream and Fly website. I've gotten some good advice, some various tips on that website, and in the forum that I posted the story of this motor, early on someone had suggested, I don't remember their screen name, so apologize for that, but they had mentioned early on that they had a real concern about the bearings inside this motor, the condition that the bearings might be in, because the motor had been sitting for such a long time, and that we had these signs of corrosion inside the fuel pump, for instance. Even though inside the actual, when I had the carburetors off and we looked at the throats where the carburetors hook up there, that looked really clean inside there. But anyways, a couple of people had said that they felt that what should be done is this motor should be torn down for, at least partially, for inspection, because the concern was that even though the motor's running, if it's got a bad bearing in there, that I could get out on the water and be running, and it might not run very long before it seizes up and causes a catastrophic failure. Well, the problem is I don't want to tear this down to that level. I mean, I've already spent much more time than I ever intended on spending on this motor. Those of you who've been following right along know that I started this project late winter, early spring of this year. The idea being that this was going to be something that I was going to be able to use on the water this summer. Well, here it is, September 11th, and you know, it's not going to be long before all these leaves are falling off the trees. I can't get anywhere with this thing because the lower gear case is a nightmare. And before I think of spending money on the replacement lower gear case, you know, a good used one somewhere even, I might want to have a better idea how sound this motor is. So the other idea that was thrown out there was, why not run the motor for a longer period of time and just get an idea of whether or not, you know, any bad sounds start coming out of the motor after it's been running for a while. Well, I've got no gear case on here, so I can't put it in a test tank and run it under load. So I figured just having it sit here and idling constantly is not great either. So my plan is I'm going to run it, and I'm going to run the RPMs up, but I'm not going to run it full throttle, because again, I don't want to run it wide open throttle with no load on it, because my RPMs might shoot way too high and cause a completely different kind of nasty failure. So the other thing that was suggested was maybe richening up the mixture, running 50-to-1 right now, because that's what's recommended on most of the boards for this motor. But I might run this richer, maybe closer to 32-to-1. It's going to smoke more, although I am using the low smoke oil, ashless or whatever you call it. But the idea being that maybe get a little bit more lubrication in there, so that maybe if there is some light corrosion somewhere on those bearings, that, you know, somehow this is going to help with that. This is all theoretical to me, but I want to do that. The other thing I did, and I never got around to testing, is I never tested my repair on my alternator. So I'm going to check while it's running and see whether or not the voltage is coming out of the alternator here, because I'm really curious whether or not this thing's working at all. So I also have a couple of little housekeeping items I wanted to take care of before I forgot. Somebody posted early on and gave me the information I needed to know about the position of these little plastic connectors here. There's two screw holes right here on the side here, and one of them is for a clamp for this wire that goes up to the alternator, and the other one is for this little clamp right here that's on the fuel line. So I might as well take care of that before I forget. And then if my test, you know, if everything pans out test-wise, maybe I'll put on the rest of the shrouds and get ready for possibly putting this thing to bed for the winter and working on
getting a gear case either over the winter or soldiering on with the parts that I have down there and seeing if I can't do anything, which is a whole nother kettle of fish. So my setup's going to be a little bit different than last time. Last time I ran the motor, I had the water going into this big pail underneath here, this old galvanized wash tub, and I had a pump set up that was pumping the water up into the power head, and I was just letting the water spill back down into the tub and recirculating. Problem was I didn't have to run it very long at all before the water became steaming hot. So that was not a good solution for running it a longer period of time. So what I'm going to do today is I'm going to just run, I've hooked the hose from the spigot on the house directly to the down tube. So I'll be able to get the water right in, using the water, the house pressure, push the water up into the head, and I'm going to let the water just spill into the tub. The tub's going to fill up and start to spill over, and I don't want to be standing in flood here of mud. So what I got is, I got this pump I picked up a while back at a thrift store type of situation, and this is a Flowtech submersible half horsepower pump. What's great about this, I got this for 25 bucks and it works perfectly fine. And they actually had this underpriced because 25 bucks was already a good deal for the pump. But what it also had with it is this doohickey right here, which has another special cord on it. And what this is this is a float switch. And the way this works is you plug the pump into this funky plug here, right? And then you plug this into your power. And what happens is the pump won't run until this float switch gets lifted. And when it gets lifted to a certain point, there's a switch that gets triggered inside here. There's a little weight that comes down and triggers this, and that'll turn the pump on. So what I can do is, instead of having the pump constantly running, is I can put the pump in there, and hopefully this will be deep enough that this switch will actually work, and it'll pump out the water as the water starts to get too high in the tub. And this is also that I can just run this thing for a long period of time. So I think what I'm going to do is I'm going to top off the fuel, start it up, get it running, maybe do my tests, get the RPMs up a bit, and then just sit here and see what happens. Another thing I'm going to do is I'm going to try this tester that I picked up at the flea market. Picked this up several weeks ago. It caught my eye. It's a Sun-Tune by Sun Electric Corporation Inductive Engine Analyzer. What caught my eye about this is that it's got a switch right here to switch from 2-cycle to 4-cycle. So it appears to me that this is usable on 2-stroke engines. So I thought, well, that's kind of neat. And it's got basically, it's an ohmmeter, an ammeter, a voltmeter, but it's also got dwell and RPM, and that's what I really wanted this thing for. All I really wanted this thing for was to have an RPM meter that I can use on this thing. And oddly enough, there's no reason why it shouldn't work. This one has an inductive pickup, and you actually put it on the secondary of the ignition coil, and the ignition coil, fires once every revolution. And so the switch here is basically just going to decide how much math it has to do to figure out what you've got. Now, whether it's a 2-stroke or a 4-stroke for the RPMs. That being said, the RPM gauge only appears to go, interestingly enough, it's got a low and a high range. The low range goes up to 1600, the high range goes up to 8000. The problem I have with this thing is that, here's a switch right here for low-high, so, alright, so I guess this will work. So I should be able to actually use this thing to measure the RPM, which, that ought to be neat, if it works. Guy wanted 15 bucks for this thing. I ended up getting him to come down on the price, because I opened it up and found out that the battery was still in here, and this uses 2 batteries, looks like a C-size battery over here, and then a 9-volt transistor battery over here, which completely was so corroded it broke the connector right off. So I'd have to open this up and replace this to be able to put the batteries in. But I'm not positive, but I think that this, for the purpose of RPMs, I think just hooking this up to the 12-volt system on the vehicle will supply the power. I think that those batteries are really only in here for the ohm meter. At least I hope so.
What's that for?
What's that for? This is called an inductive pickup. What it does is this makes kind of like a coil of wire that you put around the outside of this wire. What this does is it's able to sense the voltage going through this wire without having to make an actual, I don't have to actually like break the wire open and make a connection to the actual metal in the wire. It'll sense it. So that, because the voltage that's in this wire is high voltage. Okay, it's like a lot. That's how it's able to jump. This is what makes the spark and the spark plugs. And so it's going to be high voltage because it jumps that little gap right through, jumps right through the air. It's like a tiny lightning bolt. Easiest way to explain it. So what this does is this senses that high voltage running through this wire. Every time the crankshaft goes around twice, I think, because it's a two-stroke. So every time it goes around twice, this makes a spark. When it goes around twice, makes a spark for one cylinder, and then another, because there's 6 cylinders. So that's why this is going into this thing. This is called the distributor. This takes this spark and decides which one of the 6 cylinders on this thing gets the spark. Because you don't want them to all get spark at the same time. You only want the one that's ready for the spark, so to speak. I'll explain this more when we go through, but when we do our project, where I teach you about this stuff, we're gonna do a 4. Well, yeah, we've got the visible engine from the Smithsonian. But when we actually look inside a real motor, we'll take apart a real motor.
That's in the barn?
Yeah, that's a lawnmower engine. It's a 4-stroke. Because a 4-stroke is what you find in like just about every car, all kinds of vehicles. Okay, so let me get back to this.
You hook up on the battery?
Yeah. If this thing works, it's going to use 12 volts from the battery to actually power itself. I have no idea if this works. It's my first time using it. Oops. Probably shouldn't drop it. Here, hold that for me. All right.
Take them down again.
Yeah. It's all tangled up. Oops.
What was that?
It's Jay.
Somebody had it and you did? No, that's not Jay. Somebody trying to drive a car without putting it in drive. This is what you call a rat's nest. Alright, getting there now. There we go. Okay. So, I'll take that. We're going to put this on the ground because we put it up there, it's just going to fall down. The vibration from the motor will knock it down. And black goes on negative and positive.
RPM.
Yeah, I know. I was expecting this voltmeter to work. And it doesn't, so. I don't know. I don't think this is going to work. I think one of those 2 batteries must power a circuit. No, it's alright. We'll try it. If it works, it works. If not, we'll just play it by ear. What?
Want me to put on RPM? It's on volts right now.
Yeah, go ahead. It's not. It should already be measuring volts. It's not. All right. I gotta go grab us some hearing protection. All right. So this will be the first start. Huh?
Now.
Yeah. Go ahead. Don't open it up all the way. Turn it about a half a turn. Turn it down a little bit. Turn it a quarter turn. Turn it on another quarter turn. No. Turn it another quarter turn. Well, I'm not getting water out of the telltale again. Hey, turn it all the way on. Turn it all the way. Your full pressure and see what happens. There we go. All right. Turn it down a half a turn. All right, that should do it. All right. Remember, the camera's on, so you don't want to stand in front of there. All right. So we'll see what happens if it starts.
Working. Watch, press it again.
I'm not doing anything.
It was just doing stuff.
It was?
Yeah.
Dead.
What?
Dead.
Battery?
No, good power.
What do you think happened?
I don't know. That bucket's almost full though, and the float's not turning on the pump, so.
Oh, you know why? Because I had the pump in the wrong position.
Is it working? Now it's working.
Yeah, well, it takes a second to pump the water out.
That's not the problem. The problem. You know what? Go shut the water off. Hi, how you doing? Say, Mark? The camera's in. Alright, we're gonna go get a wrench.
What?
I got to pull the spark plug up and make sure we have spark.
Put that down, Mark.
Hey,
What?
I don't want you playing with that when I'm not out here. Don't touch anything. You shouldn't even be near it. Just in case.